I wanted to speak a bit about Elasticsearch Logs and what is happening here. Those who don't know me, like in the US, probably not that many. I'm based in Vienna in Austria, not Australia, but Austria. So I mostly travel around Europe to speak about the good stuff that we do. So I work for Elastic as part of the community team. So I have been around for a bit over 4 years, and I mostly speak around things that are interesting, hopefully. And today is no exception, and I want to dive into the Elasticsearch logs. So if you've never seen the Elastic Stack, I assume pretty much everybody has. What we will focus on is Elasticsearch in the center here. We'll use a bit of Kibana to actually run some queries, but just because it's more convenient. But it's really about the logs that Elasticsearch itself is producing. And at the very end, we'll also collect them with beats, but that's only kind of like a side effect almost. If you hear Elasticsearch and logs, most of the people think about classic ELK, like centralize your log files in Elasticsearch and then visualize it in Kibana. This is not what we're doing here. It's not about the Elastic observability. It's really the logs that Elasticsearch itself produces. So we're interested in those. So it's really about Elasticsearch. If you run Elasticsearch and start the server process, there will be a couple of log files that pop up. And the first one that you normally will look at are the server logs, which are whatever your cluster name is, .log, and there's also a file, whatever your server name is, or your cluster name is, underscore server.json. So the .log file is kind of the classic, more human-readable version, and the .json file is the JSON structured one that is then much easier to process with the stack as well. You could disable one or the other. By default, you will get both. But those are the two kind of like main log files you get for the server logs. If you have ever looked at the server logs, there is a lot of information in there, and we want to look a bit like how do you influence what is actually in there and how do you tune that. The first thing that you need to know or understand with logging, or if you've ever done logging in Java, especially with log4j, what you have is a logging hierarchy and a log level. So those two pieces, the log level is pretty much the standard, or this is the standard Java log level. So you have from trace to debug, info, warn, error, and fatal, you have these various log levels. And then you can just say like, give me everything on debug or above, for example. And then you will get all of those logs. And you can just tune that to whatever you need. By default, you would just get info and above, but you could turn it up or down depending on how many logs you want to have or what you try to figure out. Then you have the log hierarchy. The log hierarchy is really, it's not just like a global setting for all the logs that you want, but you could set it on a package level for Elasticsearch. So this maps to the code in Elasticsearch. So if I set the logger hierarchy to logger dot and then org Elasticsearch transport, this corresponds with this here org Elasticsearch transport, the folder structure. If you look at that on GitHub, so we have in the Elasticsearch project, we have a folder server, source main, Java, and then we have this org Elasticsearch transport. And this is what we're targeting here with that setting. So if you set logger.org.elasticsearch.transport, for this package, you can change the log level. And then you can say like, for this specific package, I want to have logs on debug or trace, for example, or I'm only interested in errors here. You can also change this globally. So either you can pick like specific packages which you want to turn up or down, or you could use logger dot, and then it depends on which way you use to get logs. Either you can change globally all the logs with underscore root or with dot level. And I will show you which places you use which one, because that can be a bit confusing, and it even confused me a little bit myself when I set up the demo today. So when you want to change the log levels or get more logs from Elasticsearch to figure out why something's slow or why something broken, you have 4 ways how to get to those logs or change anything. The first one is on the command line. If you run, for example, the targz version of the binary, you can just pass the name of the logging hierarchy and then the level as an environment variable to the binary when you start it. This is especially handy when you want to debug something temporarily on a single node, or when you have something that fails when you start up the node. So you cannot even get the node to start up properly. Then this is probably a good way to increase the logging severity if you don't know what is already going on. Why single node only? Because since you need to start every binary with the right command, if you have lots of nodes running, you probably don't want to restart all of them with the right configuration. So this is especially handy if you want to debug something locally and if it's around starting. So just to give you then an idea of what we have. So I have Elasticsearch extracted and we can just run it with bin Elasticsearch. So this will be the default. What was the default level where you will get the log levels? So let me switch to this folder. What is the default level of logs that you will be getting out of this when I start this? Any guesses? So when I run this, you will get logs on info or above. And you can see these here are 2 warning messages. And in a moment or so, depending on how many resources Zoom is eating, you can see we're starting our server process and you have the timestamp, you have the log level, and you have, this is an abbreviation of the package where this is from. And then you have the actual node where this is running and then the log message. So you can see this is the node starting up. And as you scroll through it, you can see here, for example, here we log that we loaded the module mapper extras, and that's the current timestamp that's Austrian time or Central European summertime. And this is where this is from. Now, let's stop that. And instead, let me run this with like a more limited log level. So if I change this to bin Elasticsearch and then I add the environment variable logger.level_warn, this will only output anything that is on warn. So all these info messages that we have seen before, let's assume they're just noise and we're not interested in them. We just want to focus on the warn messages. So I will let this run. I think 1 or 2 more warn messages will pop up as this starts up, but it is much more quiet than before because, well, only warn above is being shown. You cannot use _root for this one. This will not work. There is an issue that is, I think, almost 4 years old if we shouldn't make those two the same or only allow one, because other APIs only accept this one. But for this API, like on the command line, you need to use logger.level to actually change it globally. And you can see here, my process is starting and it has been very quiet because nothing else. Okay, now we have another warn message, but all the infos that we would have had otherwise are not shown here. And I can stop that right away because we don't need this anymore. Let's head over to the next way to configure something. That is the elasticsearch.yaml file. So there you have the logger hierarchy name, and then you set, after a colon, you set the log level. This is generally good if you run Elasticsearch as a service. So if you use something like systemd and you just do sudo service Elasticsearch start or restart, you cannot pass in an environment variable easily. So that's when it makes sense to actually change this in the Elasticsearch YAML. Or if you want to make some change more permanent and you want to bake that into the configuration of the node. Now, you have seen before the info messages when I ran this through bin Elasticsearch. Let me add the logger level warn in the configuration file. Again, this is logger.level and not logger_root. And then we can actually change that. So I will quickly change the configuration file, which is config Elasticsearch. And I will simply add at the very end, I will add this log level. And then I can just start Elasticsearch without the environment variable, and it will behave just like before, where it was only outputting the warn messages, but no other messages. So this is how you could do that, either if you run it through a service or if you want to have this setting in a more permanent fashion. Next up is the most common way to actually change the logging settings for Elasticsearch through the cluster API. So you can, once Elasticsearch runs, so the precondition is that this starts up correctly. If you target _cluster/settings, you can change the settings through the API here, which is convenient because you don't need to change any files. It applies to any node in the cluster. So even if you have 100 nodes, it's just a single REST call and it will change on all the nodes. And the other very nice thing is that this is dynamic. So you don't have to restart your node to change some logging levels, but you can just change them dynamically, which is especially nice if you want to debug something while the cluster is running and probably serving production traffic. You don't want to restart your nodes to change the logging level for that. So that's where this setting or the cluster level setting comes in very handily. I'm setting this as transient. Who knows about cluster settings in Elasticsearch? What is the alternative to transient? Anybody remembers what was the alternative to transient, or what is the behavior of transient? So the alternative would be a persistent setting. Exactly. If I do a full cluster restart, this setting will be gone. So if I shut down all the nodes in a cluster together, this setting will be erased again. Whereas if it's a persistent setting, then it would survive even a full cluster restart because it's part of the cluster settings. Yeah, exactly. As you say in the chat, this will not survive a full cluster restart. Pick the one that you want. I'll just stick to transient in my example here because it's good enough for what I want to do. So here, it's not logger.level anymore, but here you must use logger._root. And let me actually stop this process. Remove the setting at the very end. So we have the default settings here again, and let me start Elasticsearch with the default settings again. And I'll let this start up. It will take like 20 or 30 seconds. And I will also start Kibana in parallel because I want to run my queries through Kibana's console just because it's more convenient. So let me head over to Kibana. And to start Kibana, it's just the same thing. It's ping Kibana. And once Elasticsearch is up, Kibana will connect to Elasticsearch, and then we can actually use Kibana to run any REST commands against it. So the node looks like it's almost coming up again. And then Kibana will, well, take a little more time until it has started. So here you can just use the REST API cluster settings and then change any setting. While we wait for stuff to start up, how will I reset this back to the defaults? So if I change all the logging levels to Warren and I want to have it set back to the default settings. Any guesses?
Just pass in an empty string.
Yeah,
okay.
so
log root.
Yeah, so that what I always pass in is null. So null will set it to default. So what you, of course, you could now say like, I could set this to info again, but then you would set it to info explicitly and not fall back to the default that Elasticsearch has. That's when I think we added that in 5.0, so a long time ago. If you set something to null, it will basically fall back to the default API. I see a question in chat, why it's logger._root. So logger._root is basically targets all the packages. So to keep it simple, I'm not using org.elasticsearch.transport for all the transport logging only, but I just set it globally. And the cluster settings API needs this way, whereas the environment variable and the configuration file need this other way to configure it. There is a GitHub issue that we discussed to change that, but nobody ever, I don't know, had the time to actually fix that or align the APIs for that. So that is still open. That's why sometimes it's logger.level and sometimes it's logger._root. And unfortunately, you just need to know when to use which. So while I have been talking, hopefully, oops, everything has started up correctly in the background. So you can see here, Kibana is coming up. If you haven't, by the way, realized it, we have recently changed the icon of Kibana, since it's now a bit more than Kibana. It's more like the management for the entire stack. And that's also kind of what I'm using it for today. That is more the management of Elasticsearch and not really the Kibana visualization features. But it is slightly annoying because this icon is now the same as our website or documentation. So for me, it's always a bit confusing. So what I want to head to are the dev tools. And this is not what I wanted, but I have my settings somewhere else. Anyway, let me copy that in. So if I want to change this, if I want to run it with logger.level, like I said, this one is not working because this one is not dynamically updatable. That's only the other two APIs. You will need to run this one here, and this one will actually change the log level. And to reset that, like I said, if you run it with null again, so right now you see persistent settings, I didn't change anything. Transient settings, this is what I set it to. If I change this to null again, then neither persistent nor transient settings are set on my cluster. And we could just change any log level or reset any log levels here with that. Okay. The final way how you can configure something are the log4j2 properties. Let me show you what that looks like on the command line. So you have finer control here. For example, you could say I want to log to another file, for example, or I want to change when a file is rotated, but most of the time you don't really need that fine-grained control. Also, you could, for example, say this is the logger name, and then target the logger hierarchy, and then change the level of that. So this is how you change that in 2 steps correlated by unique ID. And the general configuration file here looks like, so if we had, or let me show you in logs, this contains all the log files that we had so far. So actually I wanted to show you config, and I wanted to show you the log4j2 properties in here. So if I had to config log4j2 properties, this has all the settings that are being applied by default. So for example, here we have the server JSON settings, and it sets here this uses the cluster name of my cluster, and then the file ends in _server.json. And it defines like, this is the format I want to put this out. And for example, it says like, it has a rolling file appender policy that will rotate files after 128 megabytes, etc. This is quite a long file. For most of the settings, this will be fine. So you can change whatever you want in here as well and override any log settings. So for example, for the classic log files, you have the settings here, and you could change any file rotations, patterns, whatever you want in here. But it is rare because it's sometimes a bit too much power for what you might want or need. Next up, once your server is running correctly, you might be interested in the slow logs. The slow logs are slightly confusing because there are 4 log files that are being generated for you, always starting with the cluster name. The default cluster name is Elasticsearch. That's why all of my files are called Elasticsearch_index. And then it's broken into indexing, so storing or updating any documents, and actually searching anything. And you get, again, the JSON structure and the classic.log file. The classic.log file, by the way, is kind of deprecated and will probably disappear in the future. So the .json file is the one that will be around for longer in the future. Now, how you can change something here, it's very nice that you can actually, on a per index level, you can define what is slow and what do you want to log. So here I'm saying for the index, my index, I change the settings and I say, I want to have a warn message if my search takes more than 500 milliseconds. And I want to get an info message if my search takes more than 250 milliseconds for the query part. And then you can also define that for the fetch part. So if you remember how Elasticsearch works with query, then fetch when it does a search operation. So first the query part figures out which are the relevant documents, and the fetch part then actually retrieves those documents. So you can even break that out into these two phases and say like which one is slow and what is the threshold for each. Or for storing any document, I set slightly higher thresholds where I say, if it takes more than 1 second, I want to have this logged. And I want to have like an info level if it takes more than half a second to store a document. And by default, anything above info will be logged in the slow log files. So this is kind of like the block of settings that you can apply on a per index setting. So you could have different settings for different indices. Feature-wise, you can split searches and index operations, and the search is still split into query and fetch phase. By default, slow logs are disabled, so no slow logs are being generated for you. So just to show you logs. So you can see the slow logs here, they're all empty because they're disabled by default, nothing is in them. So let's enable them and change them. By the way, there are two neat tricks you can use with slow logs. The first one is if you set this threshold to 0, it stores or logs every single query. So if you want to figure out what queries are even being run against your cluster or a specific index, you can set the threshold to 0 and it will log all the operations. And if you don't want to target a specific index, but all the indices, you can use, rather than the index name, you can use _all, because that will target all the indices. So that's how you could log all the operations for all the indices. Just be aware, especially if you use _all, this will potentially be a lot of operations. So for example, if you have security enabled on your cluster, this will add some logs every time you access something on the .security index, or every time you visualize something in Kibana. Since all the visualizations are stored in the .kibana index, those would also show up. So this one here will give you a lot of output. Just be careful with it. It's still interesting to see all the queries that are being run, but it's potentially a lot of data coming in. So let's start this one here, and let me add, let me add the right queries here. So the first thing, if you want to run this, I haven't created my index yet. If you run this operation with the settings and the index does not exist yet, this query will fail because it will tell you, well, no such index exists, I cannot apply the settings yet. So first off, you need to create the index, and only then can you change the settings. Otherwise, it will not work. So now I have set this to 0. So any search query and any index query will be logged with warn because I set the threshold to 0. So all of them will be logged. Now, if I run 2 index operations, so I add 1 document with Philipp and 1 document with Alex, will I already have something in my slow log now? Hopefully, yes. Let's check. So in my index operation, let's take this one here. Logs, Elasticsearch _ index slow log. This is the one I want. Now we have exactly those 2 operations that we ran. Since I set the threshold to 0, every single index operation will be logged. And you could see, for example, storing Philipp in the index took 40 milliseconds, and storing Alex in the index took 8 milliseconds. And this is what the slow log for index operations might look like. Now, if I run this query here, my search operation, I'm just searching for Philipp. So when I run this, this will also be logged, and this will actually, let me cheat and copy that directly so I don't have to fight my command line. So this, sorry, this is the file I want. Here, you can see this is the single query that I have ran so far. So you can see it was a query and fetch operation. It targeted one shard because since 7.0 we have a single primary shard, so my documents are in a single primary shard here. And you can see I was running this query for Philipp, and then there are some other default parameters in there, how the query will actually look like for Elasticsearch, that are all logged here. And you can see this was a super fast query. It took almost no time. Probably it took 0 point something milliseconds, but it was just very fast and it had exactly one hit. So this is how you would see how your slow search queries could look like. And then you could, of course, index that again in Elasticsearch and then figure out which are my slowest indices, or what are specific queries that are slow, or are there any very large number of hits that I hit, or what is the average took millis that I have. All of that you could easily figure out once you have these logs. So that's the slow log that you can run here. We've seen all of these here. One other very nice feature is if you run lots of queries and you want to figure out which query is this actually, you can pass a specific header to your query, the XOPAC ID, which will then be included in that log. So here, this is generally the regular query that I've been running. Only this parameter is new. I passed in, for example, the my ID here to my query, and anything that I ran with this parameter, I would find in the slow log then with this specific ID that I have been generating. So you could, for example, generate random IDs, or you could kind of group your queries by specific IDs. So you could figure out afterwards where something is coming from, or what specifically is slow, or if it's a specific user query or whatever makes sense. This here, you cannot easily run from Kibana console yet because you cannot pass any random headers in there. So we will need to fall back to the command line to actually run this. So let me head over to the command line. So here I'm passing that win. So it's a curl, it's against the same index. I'm basically running just the same query as before, only with the XOPAC ID like before. And it took 5 milliseconds now. But if I run the slow log here, this was the query that I just ran the second time. And you can now see the ID is my ID. And now you could filter down, give me only the queries, the slow query logs for anything where I have had this XOPAC ID, and then filter down on this one. So this is how you could correlate specific queries with what ends up in your logs and figure out where they come from. Okay, next up, deprecation logs. So again, you have a JSON and the log file, so there is nothing very surprising here. Deprecations, anything that will be removed in the next major version, which is 8.0, and we know of already, will get a deprecation notice. So by default, any deprecation will be logged on the level warn. You could also include the XOPAC ID header here to figure out where specific queries are coming from. And I will just pick one random example where I use a query that is deprecated by now. So let me remove these here. So I'm running a query here with cutoff frequency, and the cutoff frequency has been deprecated in 7.3, if I remember correctly. So this will generate a deprecation notice. When I run this, you can even in console, you can see here is the deprecation notice. It will still give me a result because it's only deprecated. It hasn't been removed yet, but it is here deprecated. And where this is handy is if I look at logs, oops, this is not what I wanted. Now in the deprecation log here, you can see we only had a couple of those. So I can look at not lossless logs. Here, you can see every time I started my server, it warned me that I'm currently running Elasticsearch with Java 8, which will be not supported in the future. So I should upgrade to Java or JDK 11. And here at the very end, this was the query that I've just been running. So this is telling me deprecated field, cutoff frequency used, whatever. So by default, this is on. And when you think about upgrading to a new major version of Elasticsearch, it will make a lot of sense to actually use or look at those deprecation logs to figure out what you need to change to avoid any failures in the next major version, or just to clean up continuously what should be updated so that you're ready for an upgrade in the future. So this will come in handy to figure out what makes sense here. And I think that's pretty much it for the deprecation log. Next up, the garbage collection logs. So that is gc log 0.current. And this one doesn't have a .log or .json because this is not written by Elasticsearch. This is written by the JVM directly. So we don't really have much influence on that. There is a JEP from Java directly, which specifies what is possible here and how this looks like. That would be this one here. The garbage collection log is enabled by default. You could disable it by passing in this parameter to actually disable that. So what you have here is this log here. So if I show you this one here, gc log current, this will just show you a lot of garbage collection information. So if you have the feeling that your garbage collection is taking too long or is too frequent, this is where you can figure out what this is up to. And you can see in my very small Hello World application and demo, my garbage collection is normally very fast. It takes like some fraction of a second. And it would tell me, okay, these are the stats, like these are all the locations that have failed or worked. And these are the survivors of a garbage collection. And if you have any garbage collection issues, this is probably a good point to figure out what is going on here. So you can use that one here. Okay, so much for the garbage collection logs because they're not super specific. These are pretty generic for any Java application. Finally, audit logs. So you will have a file cluster name audit.json, and audit log only really makes sense if you have security enabled on your cluster, because it could then tell you like these are all the actions that were either successful or not successful depending on what you have configured. The audit log is disabled by default, so you would need to enable it. You do that by going to elasticsearch.yaml and then you set expect security audit enabled true. And you need to note that this is a paid feature. So either you have a paid version, you use cloud, or you turn on the trial, and only then would you get the audit logs here. And then this assumes you have security enabled, so you have actually login success or authentication success or failures. There are various audit event types which you could then look at. So for example, this way you could figure out like who was successful authenticating against Elasticsearch, or who failed to authenticate, or who tried, or were there any IPs or users that tried to access my cluster, and then you could figure out why or what is going wrong there. You could even log the full HTTP request if you need to enable that. That's to be enabled explicitly again, because it might add quite a bit of logging overhead. But if you have any security compliance rules to figure out like how many failed authentication requests did you have, this is how you do that. I'll skip that because the demo takes a little longer to set up all the passwords. What you would need to do is in Elasticsearch YAML, you need to enable the audit log and you need to enable security. Then you start Elasticsearch, and then you can use this binary Elasticsearch setup passwords to actually set up the passwords interactively. Once you have done that, and you, for example, haven't configured authentication in Kibana, Kibana would try to log or query Elasticsearch without authentication, and that would already fail. And that would look something like this here. So here I'm taking the Elasticsearch audit JSON file, and this is one entry that I would have here. So you can see there is the type is an audit. You can see when it happened, the node ID. This is when I start the node for the first time. This is being generated. It was a REST request. The type of action was an anonymous access denied. You can see where it was coming from. So this was, I was running this on localhost, and it was a head request against the base URL, and the request had a specific ID. All of that would be logged, so you could figure out who is logging into your server, who is running which queries, what is failing. So any auditing on the server side is covered here. Okay, so we have collected all these logs, and now I'm using less or tail or whatever to see what is actually in my logs, which is not really what our stack is used for. So what you can do instead is you could use Filebeat, and Filebeat has these so-called modules where it can just pick up the logs automatically, knows how to parse them with ingest nodes, and then stores them in Elasticsearch and potentially even has dashboards pre-built. So what you would need to do to collect the logs for Elasticsearch by default is you run Filebeat, you use the Filebeat module with, and say, I want to collect the Elasticsearch logs. And then it would know by default, the Elasticsearch logs would be in var log Elasticsearch and then the various files you have in there. And then it knows, okay, and then you configure this is where Elasticsearch is running and this is where Kibana is running. For my setup, I'm not in var log. So you can see I'm on desktop log demo, Elasticsearch, whatever logs, and the logs are in here. So the Filebeat module wouldn't find them by default. But I have Filebeat running here, so on the same directory level as Elasticsearch. And what you would need to do then is in the Elasticsearch module, you would need to change the paths. So this is the change that I have applied here. So I'm basically telling Filebeat, go one directory up into Elasticsearch, whatever logs, and then get the server JSON log. And these are all the logs that I want to collect here. And this is, I think, already what I have configured in the Filebeat YAML. Oops, this is the file I want. So this is what I have already configured here. So now we could just run this filebeat-e. This will pick up this configuration file by default. If you scroll up here somewhere, it should tell us that it has enabled the Filebeat module. These are all the folder, or these are all the logs that it's trying to collect. And a bit further down, you can see these are the specific log files we're trying to collect here. So we have added this. Now, the one thing that we need to do here is in stack management, we need to check for index patterns because we haven't configured any index patterns yet. This will by default end up with Filebeat and under this name. And I'm just adding this index pattern here. If I would type it correctly, Filebeat. This is the index pattern I want. Give it a moment to figure out which are the timestamp fields. I want to show this by default by the add timestamp field. And then in Discover, you could just see all the logs that we have now collected from the log files that we have been creating in the background. So if I head over to Discover, these will be the logs in the Filebeat index from the last 15 minutes. And this will show, I don't know, it's always a bit of a surprise how many logs have we generated. So 40 in the last 15 minutes. If I change that to the last hour, it will potentially be slightly more. If I open one of them up here, you can see this is what we have collected. So I've taken everything from the .json file. Run my query. And these are all the fields that have been extracted. And then you could, for example, filter down, just give me the server logs and just give me everything on the level info, or just give me something from a specific host name, or just a specific file. Like all of that you could change here. For example, I could just say like, I'm only interested in the log level, log.level is, and it will then even suggest like what is available. And I'll just say like, okay, I'm only interested in the warn messages. And out of 206 messages, these will be then like only a handful or so that will remain. Okay, so we got a couple more. So these are all the warn messages that I have here. So you can see, okay, my laptop is running low on disk. So potentially I should free some disk so that I can run more demos. And this is being collected here. To have a bit of a nicer UI on this, if you had to stack monitoring, which you will need to enable. You can either do this through a click in the UI here or in the configuration file of elasticsearch.yaml. We'll just do that in Kibana through a click. So I will set up self-monitoring and I want to turn it on. And now this will show metrics of the cluster, but it will also include the logs that I have collected with Filebeat now. And it will show me in a moment, once it has this set up, it will then show me a nice UI where I can also see the logs of my cluster. So you can see here, I have one node. These are the settings. We could drill down into various details here. I'm mostly interested in the logs right now. So you can see we have 6 slow logs and we have a lot of server logs. So 63 regular ones and 10 warrants here. And if I head to that, it shows me an overview of my cluster. Since I've just started it like here, these will fill in a couple of moments. And down here, you can see all the different logs that you've had and what you have collected here. If you want to have a bit more of a curated view or drill down in those, the logs UI that we have added in Kibana is actually very nice to filter down and slice and dice your data a bit more. So in the logs UI, this is the final piece I wanted to show here. This is currently filtering down on the cluster UUID. Since I only have this one, this kind of makes sense. You could now open one of these log entries and say view details. And in the details, you would have all the individual fields. You could drag out one of these attributes here and say like, I'm only interested in warn messages. And then you can see here, my filter is now adjusting and I'm only seeing the warn messages here. You can stream this live, and as we let this run, since my disk is still more than at 90% capacity, we can watch then more messages for this coming in. That will happen every minute or so. I will get a log message of this here, that we are at this high disk watermark threshold. Okay. So I think this is what I wanted to show here. To wrap this up, you can always use more logs, especially when somebody asks us on Discuss or Slack. The first question we normally will have is, can you show us some more logs to figure out what is happening? We've seen the server logs, anything relevant to like forming the cluster or that is broken within the cluster, slow logs for any slow queries when searching or indexing data, any deprecation logs, garbage collection logs, and audit logs if you have a gold or higher license and have enabled those. The other ones, server log, deprecation logs, and garbage collection logs are on by default. Slow logs you will need to configure yourself, as well as audit logs. The way you want to generally handle your logs in Elasticsearch is you want to configure the log level through the API, as I've shown you, both for the server log or the slow log, for example. And you want to centralize them most likely in the Elastic Stack itself, so you don't have to SSH into various servers to actually pick out the logs from various machines anymore. One thing that we get quite frequently, how does this work in Elastic Cloud? The logging part in Elastic Cloud is like the server logs you can get, even though it has a slightly different UI, but there will be a way pretty soon that you can get your logs from a cloud cluster delivered into a dedicated logging cluster as well, which will then look just what I've shown you with the monitoring at the end. So then you will be able to actually see all the logs in your cloud cluster. Right now, that is slightly limited in what you can actually get from Elastic Cloud in terms of logs. And with that, do we have any other questions? Let me stop sharing and see if anybody has anything. Feel free to either write, or if you want to unmute and ask as well, if there's anything.
So in Elastic Cloud, you'll be able to change, add slow logs if you want, or what's the config? Do you know what the configuration would end up being?
So the thing is, right now, or how do you actually get the log? So by default, it will just log. So since this is Dockerized, it will log the system out. And then you cannot access those logs by default, and they could only be forwarded to like a centralized cluster right now. which would then potentially be overloaded by everybody else trying to do that. So we don't have that accessible to outsiders.
Okay.
But in the future, there will be, I think the plan, and this is only a plan, don't hold me to it, but I think the plan is that you will be able to run a beat to actually collect those logs for you and then forward them into a dedicated logging cluster for both metrics and logs. So pretty much what we do everywhere else to have that on Elastic Cloud as well. So that's the idea there.
Do you see that question in the chat?
Yeah, I see the question. Well, is it recommended? So the clients, I think most of our clients actually support the header. So it makes sense if it helps you in any way. It's not like it's required or so. But sometimes, especially if you have lots of queries running, it's sometimes very hard to figure out like where is this query coming from and how do I find a specific query? Then it might make sense to either group them by a specific header or have some unique ID, or for example, if you have requests from specific users to actually figure out all the requests for a specific user. I think there it could help you to drill down in a specific problem. Like these are the slow logs for this user, or these are the slow logs from this module or package. So you can slice and dice those a bit. That is where the XOPAC ID header is helpful for you. So you can just append it. It's not like a requirement or anything. It's just another option that you can use to make or get more value out of your logs. But it's a safe operation to do or to use. So you can use it for slow logs and deprecation logs. And I think the client supports it as well. Or depending on the client, of course. But for example, I saw that the JavaScript client recently added it and the others as well. So it is a common feature. Any other questions for Elasticsearch Logs? I know it's kind of like a dry topic, but when stuff breaks, you're always very glad when you know how to get to those, because it will make your debugging life much easier. So it's something you don't want to know, but it's good to know if you really need it at some point.
Yeah, I agree on that. It's and this is good. I mean, I haven't really seen it covered in this much detail. So this was a great talk.
Any final questions, or everybody is ready to, I don't know, head to bed? Like this is the European approach, and I guess head back to work. That is the American approach now. Yeah, so you can set like pretty much any time span that we support as timing information in slow logs is supported. So you can set it to milliseconds. So you can say like any search operation that takes more than 2 milliseconds I want to log, or you set it to 0, then it logs everything. Just be aware, if you log everything and you have a busy cluster, it will add quite a bit of overhead. So especially if you go for underscore all the indices and set it to 0, it will be a lot of logs. Don't kill your cluster just by logging. But there are no other limits that we set on that. Just be sure when you debug something, turn it up. When you're done debugging, probably turn it back down to what makes sense. Also, I mean, since we rotate the files, it will not fill up your disk so much, but it's just a lot of overhead to generate all the logs if you don't need them.